We're going to be spending a lot of our time in our studies doing a configuration of a Cisco Catalyst switch, and we want to be able to view that configuration after we make it. The way we view what is currently running on the system, it's called the running config. It's running in RAM. To see that configuration, we can do a show run. That's short for show running -config. If we do a show run, we can see screen after screen after screen of individual configuration commands. If you want to advance by one line, you can press the Enter key to slowly scroll through the output, or if you want to advance a page at a time, you can press the space bar. That's what I'm doing now. Space bar, space bar, space bar, all the way down to the end. Let me show you one shortcut. This is not in Cisco documentation that I've seen, but it's a really handy shortcut. Let's say that I was concerned about this line configuration. We've talked about the console and the VTY line configuration. Let's say we just wanted to see that portion of the config, but we had to scroll through a bunch of screens to get there. Check this out. You're going to like this. If I do a show run and I realize that line configuration, it's down at the bottom of the output. I wish I could just jump right there. What we can do is press the / key on our keyboard. That's the one on the same key as the question mark. Let's do a / and I'm going to type in the keyword of line and press Enter, and it jumps me to the first instance of the word line in this output. You see, it says filtering, and it jumps me all the way down to the line configuration, and I get to see everything after that configuration as well. That's just a bit of a time saver that I thought you might find really useful in the real world. When we're doing diagnostics, we're doing troubleshooting of a Cisco Catalyst switch, one of our most useful commands is the show interfaces command. This is going to give us a look at the statistics and the current operation of a particular interface. Before we take a look at the show interfaces command, though, let me give you another command. Let's do a show IP interface brief. Show IP interface brief. And let's not be concerned about the VLAN 1 interface right now. That's a virtual interface. What we want to focus on right now are the physical interfaces. We've got all these fast Ethernet interfaces. I think I even have, I've got a couple of gigabit interfaces as well. And right now, I've only got one of these ports connected to the network. It's the port via which I'm secure shelling into this switch. And it's fast Ethernet 1/0/1. You can see that it is up, the status and the protocol. This is valuable information. This tells me that I'm up at layer 1 at the physical layer. That's what the first up means. The second up means that I'm up at the data link layer. I'm up at layer 2. If I expect this port to be operational, then it should be in the up state. If we want to zoom in and get a bit more detailed information on that port, I can say show interfaces fast Ethernet 1/0/1. And let's take a look at some of the information presented to us. First of all, we've already seen this in the show IP interface brief command, but we are up and the line protocol is up. We're up. That's what we want. We're up at layer 1, we're up at layer 2, we're in a connected state. Another interesting piece of information, I think, is this BIA. The BIA is the burned in address. Remember that a network interface card that you might find in a PC, it has a built-in MAC address that was burned into that network interface card at the factory. Same thing with our ports on our Cisco Catalyst switches. They've got burned in MAC addresses, and there's a different MAC address for each of our ports. Another useful piece of information is the duplex. In what duplex mode are we currently operating? Recall that full duplex allows us to transmit and receive at the same time. Full duplex, do you remember? Does it use CSMACD, carrier sense multiple access with collision detection? No, it does not. Half duplex needs to do that, though, oftentimes. And here we're operating in full duplex, so no need for CSMACD. We see our current operational speed. The media type is 10100 base TX, so we could be configured to run as 10 megabit or 100 megabit per second. But here we're running at 100 megabits per second. Let's take a look at just a couple of other things. We have lots of statistics down here if we're interested in doing troubleshooting. A couple that I look to frequently are these. The CRC, the cyclical redundancy check errors. This says I have 0 of those errors right now. And another one I look to is late collisions. I've got 0 late collisions. Let me tell you why those two really stand out to me. One of the most common problems that you will probably experience when it comes to troubleshooting Catalyst switches, or at least one of the most common problems that I've faced, is having a duplex mismatch. The port on the switch is set to one duplex, maybe it's half, maybe it's full, but the device connected to the switch port, like the PC, it's set to the other. So the switch is set to full, the PC is set to half, as an example. And you might think, oh, that's not going to happen to me because my PC is set to auto-negotiate, and the switch port is set to auto-negotiate. Well, sometimes I've seen it fail. Even if you're set to auto-negotiate, it still could fail. And if you mismatch, one of the challenging things about troubleshooting that condition is that the data does get through somewhat. There seems to be slow performance on the network, but some data is getting through. But if you have a duplex mismatch, here's what I'm looking for. I'm looking for high CRC errors or high lake collision errors, and that number would be incrementing as we're trying to pass traffic. The CRC errors, they would be seen on the side of the link that was set to full duplex. The lake collision errors, they would be seen on the side of the link that was set to half duplex. Those are some of the things. Obviously, there's a plethora of information in this show interfaces output, but those are some of the things that I use most often when I'm gathering information about a switch interface. The primary responsibility of our Cisco Catalyst switch is to learn what MAC addresses live off of its various ports, and then when that switch receives a frame, that switch is going to look at the destination MAC address, and it's going to see if that MAC address has been learned off of one of the switch ports. And if it has, the switch can forward that frame destined for that learned MAC address. It can send that frame out of an appropriate port while not sending that frame out of other ports off of which that MAC address does not live. If we want to see what MAC addresses have been learned off of our various switch ports, here's a command we can use. We can say show MAC address -table. And if we scroll down just a bit, we see these dynamically learned addresses. These are MAC addresses that have been learned off of, in this case, port Fast Ethernet 1/0/1, and this is an interesting point. Notice that we have learned multiple MAC addresses off of a single interface. Is that okay? It sure is. In fact, here's what's happening. This port, or this interface, it's connected to another switch, and there are multiple devices hanging off of that other switch, and since we can get to all of these MAC addresses by going out of this port and going to that other switch, well, they're showing up in our MAC address table. So we can see beyond a next hop switch. We can see MAC addresses that are not directly attached to us. We cannot see through a router, however. If this port were connected to a router, we would see the MAC address, hopefully, of the router interface, but we would not see MAC addresses beyond the router. But we can see MAC addresses beyond an attached switch. You might also be wondering about these static MAC addresses up at the top. Notice they say CPU. Well, first of all, understand that we as an administrator, we could go in and we could statically configure a MAC address and statically say that this MAC address lives off of this port. We could make that static assignment. But these that reference the CPU port, those have special meaning in our Cisco Catalyst switches. As just a couple of examples, we've talked before about the all Fs MAC address. Do you remember what the all Fs MAC address is? That's the broadcast MAC address. And the one up top, 0100.0c.cc.ccccc, that's used for the Cisco Discovery Protocol. That's a layer 2 protocol that allows this switch to learn about its directly attached neighbors. We can see that I've got a specific model of Catalyst switch that is layer 2 adjacent to me. In other words, it's directly connected off of one of my switch ports. Maybe I've got another router that I connect off of another switch port. CDP would tell me that. CDP is also advertising to my Cisco neighbors about me. It's saying that I'm a Catalyst 3750 series switch. And we have lots of other information that also gets sent via CDP. But the bottom line is, whenever we see that the port is CPU and the MAC address type is static, these are special MAC addresses that are being used for switch features. We can configure static addresses, or we can dynamically learn addresses as we have here. A couple of other things to be aware of. When we dynamically learn a MAC address and it's entered into this table, How long is it going to stay there? Well, as long as we continue to get traffic from that MAC address coming in on a specific port, then we will continually refresh this table and keep that entry active in the table. However, if we haven't heard from that device for a period of time, 5 minutes by default on this switch, we're going to assume that maybe it's turned off, maybe it's no longer connected, and it will age out. These dynamic entries can be timed out of our MAC address table. If we're curious as to what the aging time is, I said that it was 5 minutes on this switch by default. If we want to see what it is, we could say show MAC address table aging time. Or actually just aging. And it says that the aging time is 300 seconds. In other words, 5 minutes. If I wanted to statically add a MAC address, I said we could do that. Here's how we would do it. We would go into global configuration mode and we would say MAC address table. If we give some context sensitive help, we could set the aging time to something different here, aging hyphen time, and then specify a number of seconds. Or here I could statically specify a MAC address. I could say MAC address table static, and I could enter my MAC address. For example, I could say I've got a MAC address of A820.6632.0087. And I could say that it's a member of a specific VLAN, and let's say it's a member of VLAN 1, and I could say that it lives off of a particular interface, and let's say it's Fast Ethernet 1/0/1. Now, when we go back and look at our MAC address table, if I do a show MAC address hyphen table, in addition to the dynamic entries that we've created, look at this one. Here is our statically configured MAC address. And again, this is useful if we're doing troubleshooting and we're trying to confirm that the MAC address of a device has indeed been learned off of an appropriate port.